So let's go back to our animation here. So aside from this, from what I've showed you about what I showed you about continental oceanic crust in terms of their characteristics, we can also look at plate motion. So here I can create a crust. So I might put a continental crust and an oceanic crust in there, and maybe I can show the seawater just to let you know that this is oceanic crust. It's under the water. This is a continental crust, which is obviously above the water level. And maybe we can show temperature, or maybe both temperature and density for color coding. And then now we can kind of simulate your divergent, convergent, and transform fold boundaries. Okay, so let's reset this. Let's start with continental crusts, and then let's put that into automatic mode, and then let's have that as convergent. Maybe let's pick somewhere a speed that is not so slow, not fast also, and then let's play. See, this part moves towards the other part, and what do you get? You get a crumpling effect. So part of the crustal material crumples up. Okay, so let me reset that again. If you have continental and another continental, and both of them are converging, if we play, what happens? It's not playing. I'm not sure why. So maybe let's rewind and then play. It's not doing anything. So let's just reset. Continental, continental, automatic mode, convergent boundary, slow play. You see, as this part moves towards each other, the crustal material has nowhere to go. It cannot go down because there's the mantle there. It can only go up because, this is just air. Although you can even also see some thickening of the crust here because of that crumpling effect. Okay, now you can imagine uh, uh, what geological features would be formed in that process. But again, I will not tell you what that is, although it's obvious, because we will discuss that in module 2. Okay, now because we have different types of crust, we can therefore have continental versus continental convergent, but we can also have continental versus oceanic crust. Okay, and then let's show the seawater and the labels just to uh, just for you to see that that is the case. Those are the parts. And then if we have automatic mode and then convergent boundary, if we play it, something curious happens. Let's make it faster. What happens is this oceanic crust would subduct, would go under the continental crusts. And when it goes under the continental crust, it gets melted as it reaches here, because again, that part is very hot now. If we look at the temperature, that part is very hot. So it subducts under, it gets destroyed. Again, destructive type of continental tectonic activity. It gets melted here. And of course, you can form these geological features here, which again, we will discuss in module 3. So forgive me for not um, trying to discuss them for now at least. So that's for when you have continental versus oceanic. Now we can also have two oceanic crusts. You have oceanic crust and another oceanic crust, and um, there are just because oceanic crusts could be created at any time, you can bet that if two oceanic crusts are converging, one of them is older than the other. So you have young oceanic crust versus old oceanic crust, and then let's let them converge. Again, let's make it fast. So again, just like before, one subducts under the other. It gets melted at this part and forms this geological feature here, as well as this one. Okay, but let's observe what would the young oceanic crust do and what would the old oceanic crust do. So young is, I will be putting that in the left side, and then old will be on the right side. Okay, so let's observe. Let's play. Okay. While if I do the opposite, if the old oceanic crust is in the left side and the young oceanic crust is in the right side, what happens? Let's make it faster a little bit. Right? So my question is, if you have two oceanic crust, one young and one old, which one would subduct under which plate also? Okay, so I hope you have already answered that question. Again, one more time for emphasis, if I have young oceanic crust here, old oceanic crust here, then I make them converge. Okay, so you should be able to answer now which one, which type, which oceanic crust based on age would go under and which one would not subduct. Okay, so those are the three cases of convergence. So you have again continental versus continental. You can also have continental versus oceanic. Then you can also have oceanic versus oceanic. By the way, just to satisfy the curiosity of some other people, I have continental and young oceanic versus young oceanic. Let's see what happens. And then how about if you have continental and then you have old oceanic crust? Again, let's show the seawater and the labels. Play. Okay, so now I hope it's clear to you uh, the scenario. So you can have continental versus continental. You can have continental versus oceanic. And then you can have oceanic versus oceanic. Okay? Now, in terms of divergence, you can have two cases. You could have a divergence in a continental plate. So this is continental, continental. I'll have automatic and I'll have divergent. Okay? And then I'll play it. Okay? And just for emphasis, I will show the seawater, continental, continental. I will show the seawater and the labels. And then let's play this. Oh, I'm sorry, I accidentally chose convergent. So let's reset. Continental, continental, show seawater labels. And then automatic mode, I'll choose divergent boundary. And then I'll play. Okay? So I want to emphasize this. At the start of all of that, at the start of all of that, let's play and then pause. I'm sorry, again I chose convergent type. Let's reset. Continental, continental, show label, show seawater, automatic mode, divergent this time. Play. So you notice there is this geological feature formed here, and then eventually, I hope you can see what is happening here, right? So you form an ocean at the center, right? Okay, now you can also have um, a divergence but in oceanic crusts. And then you have seawater, show labels. So it's the ocean, it's now an ocean. And if we have divergent form, you see this ocean widening, right? So again, you can have divergence in continentals, crusts. You can have divergence in oceanic crusts. So two types. And then finally you have the transform fault. So you can have continental versus continental. And I could choose transform fault boundary. And this is what happens, right? And we can also have oceanic versus, well, see, diverge, transform boundary. Okay, so again, to recap, you can have convergence in continental versus continental. You can have continental versus oceanic. The oceanic will subduct under the continental crust. You could have oceanic versus oceanic. You simply find out where is the younger one, and the younger one stays above. The older one would actually sink at the bottom. Okay? And then for divergence, you can have divergence in a continental crust. It breaks open. You can see cracks at the center, and then eventually it forms a sea. And or you can have an oceanic crust already and it diverges, making the oceans wider and wider even more. Okay, so I hope that clarifies the interactions of type of plate tectonics. I mean, on the types of plate boundaries, especially the role of the type of crust into what will happen during the interaction. Okay, so again, forgive me if I did not elaborate further on the geologic features that will be formed. I am reserving that for module 3, three's discussion. Okay.